Now in complex analytic function, we will be proving the complex integration theorem. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now come to the complex integration. Okay, we're finding the integration of a complex number, right? As we know that the function f of z will be having a real part and imaginary part, right? But the integration would be as in a normal real function integration. Okay, if you consider an analytic function f of z, which is equal to u plus iv, a function of x and y. Okay, to find the integration over the path c, such that it will be in between a and b. Okay, now if you consider graph here, you know that this is a real part of an z, and this is nothing but an imaginary part of an z, right? And from point a to point b, if you want to find the integration, okay, then you have to know the function f of z. When the function changes, then we have any different values for it, right? So the f of z should be defined for it. Now we have to find the integration of it. But general thing that we know is nothing but z is equal to x plus iy. And if you consider x is a function of t and y is a function of t, and t belongs between a to b, okay, then you have to find the integration of f of z dz. What is a dz? As we know that z is equal to x plus iy, then we get dz is equal to dx plus I dy, right? And f of z is equal to u plus iv, and runs a closed path we are considering. Now from a to b, it becomes a path c, right? So just really substituting the values, it becomes integration over c. F of z is equal to u plus iv into dx plus I dy, right? So when expanding it, get this one as nothing but integration over c. It becomes u into dx minus v into dy plus I into close curve. It becomes v into dx plus u into dy, right? Now if you consider dx is equal to dx by dt into dt, and dy is equal to dy by dt into dt, and we can write this particular function as integral over c. It becomes u into dx by dt minus curve c becomes v into dy by dt into dt plus I into close curve c. It becomes v into dx by dt into dt plus I into integration of close curve comes u into dy by dt into dt, right? So by finding the value of dx by dt and substituting the v values, we get the function, right? Now we have to integrate 4 times, right? So it becomes very complex. So we will be going with an Cauchy's integral theorem, okay? To solve the problem very easy, okay? We'll be using Cauchy's integration theorem, x integral theorem, okay? So if you consider a function f of z, which is equal to u plus iv, where u and v are a function of x and y, okay? We are analytic on and inside, okay? A simple closed contour C, and let us consider f dash of z. We also continuous on and inside C. That is not what f dash of z should not be equal to 0, okay? As we know that if you consider a graph here, as you know it is a real part of an z, and this is nothing but imaginary part of an z. Now if you consider closed contour, okay, f of z known as c, okay, then we can directly see that integration over a closed contour f of z dz is equal to nothing but 0. we'll try to prove it. Okay, as we know that integration closed curve of a c f of z dz is equal to nothing but integration of u plus iv into dx plus idy. We'll try to expand it. We get nothing but integration of closed curve. It becomes u into dx minus v into dy plus I into integration of closed curve becomes b into dx plus u into dy. Right. Now we'll be solving this particular equation by using Green theorem. Okay. First we'll understand this one equations. Okay. If you consider the first term, okay, u into dx minus v into dy, where the closed curve will be integrating. Right. So it will be going with this particular equation. You can see that integration of closed curve p into dx minus q into dy is equal to minus of double integration of dq by dx plus dp by dy dx dy. So we'll be solving here. Get this one as minus of double integration of here u is nothing but p and v is nothing but q. So when you substitute it, you get dv by dx plus du by dy into dx dy plus I into, come to the second term. It will be going with this particular equation, right? So integration of closed curve p into dx plus q into dy is equal to double integration of dq by dx minus dp by dy dx dy. Now here p is nothing but v and q is nothing but u. So we get double integration of, it becomes du by dx minus dv by dy into dx dy. But we know the causes Riemann equation, right? It's nothing but du by dx is equal to dv by dy and du by dy is equal to minus dv by dx. Now we are solving for only for v values. Then we get minus of double integration of dv by dx is nothing but minus of du by dy plus du by dy into dx dy plus I into double integration of du by dx minus dv by dy is nothing but du by dx into dx dy, right? Now these two terms will get cancelled and it becomes 0, and these two terms will get cancelled and is equal to 0. So 0 plus 0 is nothing but is equal to nothing but 0, right? So when you consider an analytic function and you have to find the integration of a closed curve, okay, then f of z dz is equal to nothing but always it will be equal to 0.